Okay, there you go. Good, working. So here's another one that is quadratic in nature. You might look at this and you might freak out a little bit, but you know who's not going to freak out? That's right, he's got two thumbs, and it's this guy. So, that's right, this is not a laugh track. There are real people in here. So, what is the, thank you. What is the complicated guy in this problem? Other than me, the fraction, right? So, if we let u equal the crazy fraction, in this case, x plus 4 over x minus 5, and understand it's just that variable part. Don't include the coefficient. The coefficient, we'll get to him later. He's not what the u is going to represent. But if I let u equal this guy right here, that's also going to be representing this guy right here, who has the square, which is going to make him look what? Quadratic. There we go. Quadratic is the word we're looking for. So now I'm going to rewrite this, and it's going to be 3. Good, 3. I'll try 3. And instead of crazy fraction, you write what? U to the second power menos 8. That means minus 8. And then there's another u plus 4 equals 0. Isn't that great? Now, which equation would you rather try to solve? Crazy fraction guy? Well, here's this cute little quadratic. He's so cute. Right? Basically, you took a panther and you declawed that, and now you have a cute little kitten. So what am I going to do with this guy? It's okay to say the F word? No. Factor, that's right. Thank you. We're going to factor this. So at least we hope we can factor. Maybe off to the side we do that AC method again, right? AC being 8 times C equals what? I'm going to take the 3 and the 4. That product is 12. I need to find factors of 12 that do what? Not that go into 8, but we want them to add to get 8. That's the key phrasing there. So, what are the factors for 12 to add to 8? 2 and 6. Now, we could take this guy, split up the middle term like we've done for the AC method, factoring by grouping and all that jazz. But notice the 3 here. This guy is prime. So there's only one way to factor 3u squared. And what is it? 1 and 3. So let's go ahead and just do that. We're going to say 1u and 3u. And I can't just go straight to factoring 4, because 4 has 2 different options. But 3 being prime, you can only do 1 and 3. So use logic to help yourselves out here. Now, the 3 to me is the outlier. Will this 3 be used to form the 2 or the 6? He's going to be used to form the 6, right? You're not going to say, 3 times something gives me a 2. Yeah, 3 times 2/3, and I bet you're not going to write 2/3 here, are you? No. How are you going to get the 6? 3 times what? 2. Well, that means that 4 breaks down as 2 times what? 2. Awesome blossom. Now, check everything here. You're going to get a 6u on the inside. You're going to get a 2u on the outside. Well, 6u and 2u give you 8u. 6 and 2? Yes. Please don't make this a video that I cannot upload. I don't edit. That's right, it's all on you. Don't blame anybody else. All right, so what signs will you use so that you multiply to get a positive but add to get negatives? Negative. Both of these guys are negative. All right? Then using the zero factor theorem, that means u equals what? U equals 2, or over here, u equals what? You would add 2 divided by 3. Now remember, u was just a placeholder. He was a fill-in, right? Will the real variable expression please stand up? What does u really represent? It's not x. It's x plus 4 over x minus 5. See, this guy is just messy. Once we took him out of the picture and used u instead, we had a nice trinomial that factored, and we got down here. So now x plus 4 over x minus 5 is equal to 2. And to make this easier on ourselves, let's just go ahead and say that's 2 over 1. So now what kind of equation have I created by saying x plus 4 over x minus 5 equals 2 over 1? What's that special word? Okay, I don't know what you're doing there. Is that a gang sign?
No. I was thinking about the cross multiplication.
Oh, you don't say cross multiplication in my class? What was that?
Cross product.
Cross products, right? Because we have a proportion, right? A proportion being one fraction equal to another fraction. That's a proportion. And in a proportion, we set the cross products equal to each other. So one cross product here of x plus 4 times 1 gives us x plus 4. The other cross product of 2 times x minus 5 gives me what? That's 2x minus 10. If you need to show the distributive property before you get here, that's fine, but hopefully with practice we can just get here. Where would you like to move your variable terms?
The right side.
Yeah, let's go ahead and move those guys to the right. So I'm going to subtract x on both sides while at the same time doing what?
Adding 10.
Add 10 to move the constants back to the left. So on the left side of the equation, 4 plus 10 is 14. 2x minus x equals x. Now, I've got this nasty habit of wanting to go ahead and box an answer once I get to it. Does anybody else feel that way? But you've got to be careful because we started with something that was rational up here, right? And as we saw yesterday, if you have a rational equation, you have to watch out for restricted values. What value of x could I never have for a solution here? Positive 5, because it would make my denominator equal 0. Well, do I have 5 as my solution? No. So this guy should be fine as long as I've done my math correctly, which we all know I have. On the other side here, what is the other half of this equation going to give you? What is u?
X plus 4 over x minus 5.
Still the same thing. X plus 4 over x minus 5. And this is equal to 2 over 3. So just like we did on the left half here, we can still say that the cross products are equal. So this first cross product of 3 and x plus 4, what is that?
3x plus 4.
I'm sorry, what was that? 3x
Plus 4.
plus 12. When we distribute the 3 times the x and the 4, right? This other cross product here of 2 times x minus 5 is what?
2x minus 10.
That's 2x minus 10. If you are not seeing how we get here, then you need to consider what this looks like off to the side, where you have 3 times x plus 4 is equal to 2 times x minus 5. If you need to write that first and then distribute, that's fine. Okay? But back over here to our equation, where would you like to move your variable terms? I would subtract 2x to move it to the left. And again, my reasoning for doing that is so that you end up with a positive coefficient for your lead term at the end. If my variables move to the left, your constants go where? To the right by subtracting 12 on both sides. So 3x minus 2x is x equals negative 22 on the right. What did we say our restricted value was?
5.
Positive 5. So do we have that as an answer? No. So again, as long as we've done the math right, we can just box that answer, and both of these guys are good. So just to recap, we had something that was complicated with all these fractions, but by seeing that these guys are exactly the same, we rewrite that as something simpler, like a u. You could use something else if you want to use a smiley face or another letter. I don't really care. You could use like a big square. Does not matter. But you do that so that you can factor. A lot of times these guys do factor and then you take these guys and their solutions from the zero factor theorem, and you go back to the original, and you solve these new equations. And you're done.